Let's take a look at some more examples of the ambiguous case for the law of sines. So let's say, for example, you have a triangle that has an alpha value of 35 degrees, a b value of 8, and an a value of 6. So we start out and we say, okay, well, the sine of alpha over a should be equal to the sine of beta over b, which means that the sine of beta is equal to 8 times the sine of 35 over 6. So let's go ahead and get a value out there. So this would be the sine of 35 times 8. We'll divide that by 6. I'm getting 0.76. So that means beta is equal to the arc sine of 0.76. So there's two values that are going to come out here. So 49.9 roughly. So beta is equal to 49.9. And the second beta value that comes out is 180 minus 49.9, which is 130.1. Now if we take a look at the second value, so we have to check this guy over here. So we say, okay, if we take our alpha value and we add it to our second beta value, do we stand for 180? And we do. So since 130.1 plus 35 is less than 180, we have two triangles. So let's set up our two triangles. Okay, so triangle 1. Okay, and we'll draw triangle number 2 over here. I'm going to make them look the same. It's really irrelevant. So 35 degrees, 49.9 degrees, and 130.1 degrees. So let's get our remaining angles. For triangle number 1, we'd have 180 minus 35 minus 49.9. So that gives me 95.1. Over here, on this triangle, we'd have 180 minus 130.1 minus 35, so 14.9. Okay. We know that A is 6, so this length is 6 on both of them. B is 8. So the question is, what's the remaining side? Well, this one, the first one's going to be longer because it's got a 95-degree angle across. The second one's going to be really short because it's got a 14.9. So there's two separate triangles here. So to figure that out, my C value is going to be equal to, I'm going to go 6 times the sine of 35 over, oops, let me just make sure I've got that correct. It looks right, but I just want to do the math out a little bit more here. So this is going to be sine 35 over 6 has got to be equal to the sine of 95.1 over C. So in other words, let's just do it down here. This is going to be C is equal to 6 times the sine of 95.1 over the sine of 35. So let's go ahead and do that out and see what we get. So 95.1, I want the sine of that guy, multiplied by 6, divided by 35, the sine of that guy. I'm getting 10.41. Okay, so let's go ahead and we'll write that down, or 10.42, I guess, roughly. So 10.42. And now we'll do the same thing for this one. I have c is equal to 6 times the sine of 14.9 over the sine of 35. So the only thing that's changing here is the angle. So let's go back. So 14.9, the sine value of that, multiplied by 6, divided by the sine value of 35, and that gives me 2.69. So with this given information, there are two possible triangles. Triangle number 1 and triangle number 2. Okay, let's keep going. Let's try another problem here. We have enough time in this video. So let's say we've got a situation like this, where alpha is equal to 50 degrees, A is 2, and C is 1. So we would say the sine of 50 degrees over 2 is equal to the sine of gamma over 1, or C. So we'll go ahead and solve this, and we get sine gamma is equal to sine of 50 over 2. So we'll take the sine of 50. Oops. Let's go back here. So I've got, oh, whoops, I wanted to set this problem up differently. So just ignore what I just said. Let's go like this. Let's say alpha is 50, and our A value is 1, and our B value is 2. So then the sine of 50 degrees, or 1, is equal to the sine of beta over 2, which means the sine of beta is equal to 2 times the sine of 50. And the sine of 50 is 0.76, and we multiply that by 2, we get 1.53. So notice now here I can stop, because I'm looking for an angle whose sine value is 1.53. And there's no angle that has such a sine value, because sine values have to be between -1 and +1. So this has no solutions, or no triangles. There are no possible triangles that have an angle of 50 degrees with an opposite side of 1 and an adjacent side of 2. So that kind of gets you through some of the different things that you can expect to see with the law of sines and the ambiguous case.